today's world, our planet is suffering due to the high amounts of CO2 being released into the atmosphere, and responsible for about 42% of these global annual emissions is the built environment. Within the built environment, materials like steel and concrete contribute greatly to this detrimental statistic. In an attempt to remedy this unfortunate truth, we must find a material that can compare in both cost and durability to materials like steel and concrete. Here, we must turn to one of the only completely sustainable resources on Earth: wood. While the use of timber in construction can be traced all the way to 100 BC, its modern form of mass timber was first created in Austria and Germany in the 1990s. To give some context, mass timber is an engineered product that uses current technological advances to connect wood layers into one singular mass. This process results in structural elements like panels, beams, and posts. Mass timber has rapidly increased in popularity due to its natural regeneration, durability, and versatility, all while having a low carbon footprint and using less water and energy in its production than both steel and concrete. Additionally, it is quite clean to construct, which even further reduces its carbon emissions during production.
To put strength into comparison, traditional buildings utilize concrete for its compression strength, with steel rebar to reinforce its tensile strength. While this combination leads to an overall strong and long-lasting building, these materials are reliant on each other to achieve this strength, whereas mass timber alone has strengths in both tension and compression that, when put together in a system, has the ability to create a structure with comparable strength to traditionally constructed buildings. According to airfixture.com, mass timber is $14 less per square foot than a steel and concrete building, and on top of this is built with locally sourced materials. Not only does this lower its transportation cost, but even further decreases the carbon emissions put out by the product as a whole. While concrete can be locally sourced due to the abundance of gravel, sand, and water nearby most construction sites, these materials are non-renewable, while mass timber can be replenished. Additionally, steel typically has to be transported over long distances to reach the construction site, making it a much less viable material than wood.
There are many different types of mass timber, but here are some of the more popular options. Cross-laminated timber, or CLT, is one of the most used forms of mass timber. It is constructed by layering dimensional lumber at 90 degrees and then gluing and compressing these elements together with a durable and moisture-resistant adhesive. Next, there is glue-laminated timber, or glue-lam. These components are constructed by layering dimensional lumber on its side and bonding them together with adhesive. Then, there is dowel-laminated timber, or DLT. Unlike the previously mentioned components, DLT is made with strictly wood and no adhesive. This type is friction-bound using dowels to connect the planks side by side. All of these different types used in conjunction are what contribute to the overall strength of a mass timber building. Located in Minneapolis, Minnesota, and designed by Michael Green Architects in 2016, T3 is a current example of what a mass timber structure can do. Standing 7 stories tall and made predominantly out of glue-lam and nail-laminated timber, T3 is not only less energy intensive, but the carbon is actually sequestered within the wood throughout its lifetime, totaling about 3,200 tons within this project alone. On top of all this, the use of mass timber also saves time in the construction process, which can be a major contributor to carbon emissions. In just 2.5 months, the building was completed and ready for use, which is far less than conventional buildings. T3 is a great example of the benefits that mass timber can bring to the world of construction. To determine if mass timber really is a good candidate to replace concrete and steel, we can look at something called the life cycle assessment. This tool can be used to analyze the lifelong environmental impact of a project or object. The way that it works is through the investigation of a material's life cycle, starting with sourcing the material to its disposal or recycling and quantifying the effects. The Society of Wood Science and Technology has conducted a life cycle assessment on cross-laminated timber. Compared to a building constructed with concrete and steel, the results reflected an 18% reduction in global warming impact. Additionally, in this project, mass timber replaced 58% of concrete and 72% of the rebar that is typically used in a building. While there are many advantages to mass timber construction, no building material comes without a fault. One flaw in mass timber derives from the collection of its resources. If this form of construction were to grow in popularity, lumber companies would take a huge hit to their stock. While it has been predicted that future timber construction will not outweigh forest inventory growth, it would still be a safe bet to increase the farming of lumber. Not only would this increase the supply for current projects, but it would allow for more mass timber buildings to be produced around the globe. Another potential concern with mass timber is its vulnerability to mold and water damage during construction. One way to limit this is to cover up the timber elements with tarps on rainy days to ensure that no moisture gets within the fibers of the wood. Additionally, to further prevent the infiltration of water damage, proper insulation of a mass timber building is essential to the longevity of its lifetime.
One of the largest speculations to mass timber is the concern over its high flammability due to its wooden properties. In reality, mass timber is actually more fire resistant than its steel and concrete counterparts. While steel can only retain its strength in temperatures up to 700 degrees Fahrenheit, a test done on cross-laminated timber proved it could retain its strength in temperatures exceeding 1,800 degrees Fahrenheit. This is due to the slow and predictable charring capabilities of mass timber that allow it to greatly surpass the required 2-hour fire rating that building codes require.
Amid environmental concerns linked to concrete and steel, the ongoing search for alternatives highlights mass timber as a renewable, affordable, and durable material, with successful applications in various projects, even right here in Minneapolis. As time passes and technology develops, mass timber has the potential to adapt and become even better and more applicable in the future, ultimately contributing to an overall more sustainable planet.